Rational expressions. Let us talk about rational expressions. Shortly, rational expressions are defined as quotients of polynomials. Let's take two polynomials, p of x and q of x. P of x over q of x, whenever q of x never be zero, is rational expressions. If a function or an expression can be expressed like this, it's called a rational expression or a rational function. This is when the denominator q of x is never be zero. As I said, the numerator p of x and the denominator q of x are both polynomials. Let's see examples on rational expressions or rational functions. The first example, 2x plus 3 over 5x squared plus 9x minus 4. The numerator 2x plus 3 is a polynomial and the denominator 5x squared plus 9x minus 4 is also a polynomial. So this expression is a rational expression. Next example, 6x cubed plus 4x minus 7 over x squared plus 1. Again, this one is a rational expression because the numerator and the denominator are polynomials. Next example, 2 over x cubed minus 1. Again, this one is a rational expression because both the numerator and denominator are polynomials. Next example, x cubed plus 4x minus 1. Again, this one is a rational expression because the numerator x cubed plus x minus 1 is polynomial and its denominator 1 is also polynomial. The last example, look at this one, 2x squared plus x over square root of x plus 1. This is not rational expression because the denominator square root of x squared plus 1 is not a polynomial. After we have seen definitions and examples of rational expressions, let us go to some concepts on the domain of rational expressions. The domain of rational expression is any value of x that doesn't make the denominator q of x 0. Let us clarify it with examples. The first example, 2x squared plus x over 6x plus 3. We only focus on the denominator, that is 6x plus 3. So find the value of x when this denominator is going to be 0, then x becomes negative 1 over 2. So any value of x except this negative 1 over 2 can be considered as the domain of the rational expression 2x squared plus x over 6x plus 3. This means any value of x except negative 1 over 2 can be applicable on this function or can make it defined, but the value x is equal to negative 1 over 2 can make the function undefined because it will lead to the denominator to be 0. The next example, 3 over x squared plus 5x plus 6. Let us focus on the denominator, that is x squared plus 5x plus 6. So let this function gonna be 0. And then we find the value of x, but before that we have to factorize this polynomial. When you factorize it, it becomes x plus 2 multiplied with x plus 3. So finally we will get the value of x negative 2 and negative 3. These two values make the function undefined. So the domain of 3 over x squared plus 5x plus 6 is all the real numbers except negative 2 and negative 3. The third example, 5x plus 9 over x squared plus 1. We only focus on the denominator x squared plus 1. Gonna to be 0. Let we make it 0. But if you see, this x squared plus 1 can never be 0. So the domain of the function or the expression 5x plus 9 over x squared plus 1 is real numbers. This means all values of x can be applicable on the function. This is all about the definition, the introduction of rational expressions or rational functions and the domain of rational expressions. In the next lecture, we will see some other portions on rational expressions and rational functions. Until then, have a nice time and thank you for watching.